Hey there, and welcome. So, you're an experienced Java developer, and you're probably asking yourself, what's next? Well, you've come to exactly the right place. In this explainer, we are going to lay out the complete A to Z curriculum to help you make that big strategic leap from building applications to architecting the massive data pipelines that power, well, pretty much everything these days. So, let's just dive right in. We're going to break this whole journey down into 6 key phases. We'll kick things off with the skills you already have. Then we'll build a super solid foundation, dive deep into the data ecosystem, learn how to orchestrate entire systems, level up to cloud architecture, and finally, the best part, we'll give you a concrete action plan so you can start literally today. All right, first up, let's talk about your biggest asset. We're going to explore how your background in Java is actually the perfect launchpad for this career shift. What's so cool about this is how directly your skills translate. This quote from DataPow just hits the nail on the head. If you've ever dealt with performance tuning, optimization, or building reliable distributed systems in Java, you are way ahead of the game. That's the perfect foundation for a career in data. The really crucial thing to grasp here is that it's all about a shift in focus, right? As a Java dev, you've totally mastered application logic and managing state. Now, as a data architect, you're going to apply that exact same rigorous thinking to things like data integrity and how information moves across these huge distributed systems. The principles are identical, just the domain is different. Okay, next up, let's build out that foundation. We're going to cover the absolute non-negotiable skills that every single data architect needs in their toolkit. It is so easy to get distracted by the latest shiny new tool. But trust me on this, the most successful architects are the ones who master the fundamentals first. And why is that? It's because tools come and go, but the core principles, how data moves, how it's stored, how it's processed, those are timeless. So how do you actually start? Here is a super concrete plan for your very first week. You're going to want to really get good at advanced SQL. I'm talking about powerful stuff like window functions for complex calcs and CTEs, which are just common table expressions to make your code readable. Then get comfy with Python for data work using libraries like pandas. From there, it's about owning the Linux command line, understanding containerization with Docker, mastering Git for version control, and finally just dipping your toes into one of the big cloud providers. This is your launch sequence right here. With that foundation in place, let's start exploring the ecosystem. We'll break down the 3 core pillars of any modern data stack. That's storage, batch processing, and real-time streaming. Just think of it like this. Storage is your library, right? It holds everything from massive raw data lakes to highly structured data warehouses. Batch processing, that's your scheduled large-scale factory work that runs overnight. And then stream processing is your real-time assembly line, handling data the very second it arrives. And here it is. This is where your Java background gives you an absolutely massive advantage. 2 of the most powerful data processing engines out there, Apache Spark for batch and Apache Flink for streaming, both run on the JVM. You already get its memory model, you understand performance tuning. Spark is your go-to for that heavy-duty ETL and analytics, while Flink just shines at low-latency real-time stuff like fraud detection. Now, on the storage side of things, you'll be working with data lakes like Amazon S3 for all your raw data, these modern lakehouse formats like Delta Lake that bring structure and reliability to those lakes, and of course, powerful cloud data warehouses like Snowflake or BigQuery for business-ready analytics. A true architect knows exactly which tool to pull out of the bag for which job. Okay, so you get the components. Now, let's talk about orchestration. This is all about leveling up your thinking, from just writing code for a single task to designing a complete, automated, and totally integrated system. The whole data factory idea is the perfect metaphor here. You're not just building individual machines anymore, you are designing the entire assembly line. You're making sure that raw materials move smoothly from one station to the next, with quality checks and error handling built right in. That is orchestration. So what tools do you use to build this factory? Well, this slide breaks down the top 3 players. You've got Airflow, which is the mature, battle-tested standard for big companies. Then there's Dagster, which takes this really cool developer-first, data asset-aware approach. It's fantastic for ML pipelines. And you've got Prefect, which offers a super flexible, API-driven model that's perfect for teams that need to be nimble. And how do you structure the factory's workflow? The medallion architecture is a best practice design pattern everyone uses. It's simple. You land your raw data in the bronze layer, no changes at all. Then you clean it, you structure it, you put it in the silver layer. And finally, you create these aggregated business-ready tables in the gold layer for your analysts and data scientists. This system ensures quality and reliability from start to finish. This brings us to the final climb, moving from engineer to architect. This whole section is about the big picture concepts and the cloud platforms that define modern data architecture.
You cannot, I repeat, cannot be a data architect without deeply understanding the CAP theorem. It's a fundamental law of distributed systems, like gravity. It basically forces you to make a really tough trade-off. When the network fails, do you choose to keep your data perfectly consistent, or do you choose to keep the system available for users? Your answer to that question has absolutely massive design implications.
And where are you building all these amazing systems? On the cloud, of course. AWS, GCP, and Azure are the big three. A modern data architect has to be proficient in the data services of at least one of these platforms. They're the bedrock that everything else is built on top of. Now, a fantastic way to structure your learning, and let's be honest, to validate your expertise is through certifications. But don't just think of these as lines on a resume. Think of them as guided curricula. The Google and AWS certs are amazing for cloud platforms, while the Databricks and Confluent certs prove you're an expert in critical tools like Spark and Kafka. Woof! We have covered a ton of ground. So in our final section, we're going to turn all of this knowledge into immediate, concrete action. This is where the real transformation starts. Here it is, a totally manageable 4-week sprint to get you going. Week 1 is all about those foundations we talked about. Week 2, you're diving headfirst into storage and batch processing with Spark. Week 3, you tackle real-time streaming with Kafka and orchestration with Airflow. And then in week 4, you bring it all home by building your very first end-to-end project. And look, to remove any and all friction, here is your literal homework for today. These are 6 things you can do the second this explainer is over to start your journey. Get your environment set up, create your first project repo, and yes, go update your LinkedIn headline. Start positioning yourself for the role you want. No more excuses. As we start to wrap up here, I really want to leave you with this one crucial thought. This entire journey, it isn't about memorizing an endless list of tools. It's about developing an architectural mindset to understand the problem first and then choose the right tool for the job. The path from a Java developer to a data pipeline architect, yeah, it's challenging, but it is also incredibly rewarding. We've just given you the complete A to Z roadmap. So the only question left to answer is, when are you going to take that first step? Thanks so much for watching.